This video gives a brief overview of how to work with numerical, textual, and logical data in MATLAB. All MATLAB variables belong to a class, sometimes known as a data type. The different classes have different characteristics and are suited to represent different types of data. Let's first look at representing numerical data. We will create a variable a and assign it a numerical value. You can see the class of a variable in MATLAB with the whos command. We see a is of class double, which stands for double precision floating point array, which is the default numerical class. You can also see the class of a variable in the Workspace browser. We will hide some other columns to make more space. When displaying floating point numbers, you can change the number of digits displayed with the format command. For example, you could specify one of the options which show more digits, such as format long. Format short is the default. Note that the format command only changes how numbers are displayed and does not change their actual values. Many operations can be performed on double arrays, including hundreds of mathematical functions. Double precision numbers can also be complex, with I used to denote the imaginary part. To find out more about using doubles, see the Numeric Classes section under Programming Fundamentals. Double arrays are represented using 64-bit double precision floating point numbers. You can also store numerical data at a lower precision. Options include single precision floating point numbers, for which most mathematical operations are supported, and integers, which primarily just support arithmetic. Note that most of these data classes require less memory than doubles. We will now look at representing other non-numerical types of data. Logical or Boolean values, which can either be true or false, are stored in logical arrays. MATLAB has special names for these two values. D1 equals true, D2 equals false. Note that true and false are displayed as 1 and 0 respectively. Logical values are created by relational operators. For example, given the variable a less than 5 is true. And are used in flow control statements such as if a less than 5, display in range. To find out more about using logical arrays, see the documentation. Textual information, such as strings or individual characters, is stored in a char or chart array. You specify a string or character constant with single quotes. All MATLAB data classes are arrays. You can manipulate character arrays just like other arrays, such as with indexing or concatenation. Sometimes it is useful to convert a numerical value to a string and vice versa. For example, if we had a loop index k with which you wanted to construct a string, you could use the num_to_stir command. To find out more about the operations you can perform on strings and character arrays, see the documentation. The elements in the arrays of data we have represented so far have all been of the same type, or have been homogeneous in nature. If you need to represent information that is more complex, containing heterogeneous data of different types or sizes, this can be done with structures and cell arrays. See the video introducing structures and cell arrays for more information. And finally, you can define your own custom classes in MATLAB. See the Object-Oriented Programming section for more information, or watch the introductory video. That concludes the demonstration. Try these features in MATLAB now, or watch one of the other videos.